Hi, in this video we're going to take a look at this ToolTop ET75 process meter. Now, process meters are mainly used in industrial settings, typically for loop calibrations. So ordinarily, you wouldn't come across it as a hobbyist, let alone using one. But these meters have some unique features. For example, this one can source and sink current up to 20 milliamps and also can output around 24 volts, which can come extremely handy in a lab setting outside the intended industrial use. For this reason, I requested this ET75 from Banggood and wanted to take a closer look at it in this video. As usual, I will provide a product link in the video description below for those who are interested in getting one. In an industrial setting, a process meter can be used to troubleshoot control loops that use 4 to 20 milliamps current signaling, such as the HART protocol. This industrial standard has been around for a long time, long before modern electronics. As to why this standard was chosen, it's actually quite fascinating to read about. Since this is not the purpose of this video, I'm going to just leave a link to the Wikipedia page in the video description below, in case you are curious. But in general, using current as opposed to voltage as control signals has a key advantage. That is, it is less susceptible to noise. Anyway, this ToolTop ET75 is at just around $100, which is relatively inexpensive for a process meter. It actually has most of the features of a multimeter. For instance, it can measure DC voltage up to 50 volts, AC voltages up to 600 volts, and it can measure current up to 20 milliamps. For resistance measurement, though, it is limited to 5 kilo ohms max. While this might not meet all your measurement needs, you definitely can use it as a very basic multimeter or voltmeter at the very least, especially for working with low voltage electronics. And the spec accuracy in most of the ranges are within 0.5%. For current measurement, it's even better at 0.2%. The meter does come with a manual, and you can see from the manual here, we do have some of the specifications I mentioned earlier, that you can see the DC voltage range is indeed only 50 volts, and AC goes up to 500 volts. And we have a continuity diode, DC current measurement, and so on and so forth. So that's pretty much the functionality of this meter. It also comes with a soft carrying pouch, and we do have a couple of alligator clips and a couple of spare fuses by the look of it. Since this meter does have the multimeter functionality, let me first go through these basic measurements, and then we will take a closer look at these unique features. The first test we're going to do is to verify its AC measurement performance. And I'm glad I just double-checked again because I had the probes in the wrong range. Now I just swapped it to the correct measurement range, and let's turn on the Unity UT61E as reference, and we'll turn on this meter as well. And by the way, the switch on this ET75 feels pretty decent. It is a little bit soft, but nevertheless it is pretty accurate, and you can see that it lands on the intended range very precisely. And let me move this screen a little bit. There is a little bit of glare, unfortunately. But you can also see that the display is actually very sharp on this ET75. And let me turn on the variac. You can see that we're actually reading a little bit higher than the Unity. Now that's probably at least 1% out. So not entirely sure what the deal is. Let me increase the voltage a little bit higher and see what we get here. Oh, by the way, you can see that at around the 30 volts mark, you see the high voltage indicator comes on. And that's the same on the Unity as well, you can see. So that is all good. Let me increase to 50 volts. Yeah, you can see that we're consistently a little bit of higher. So I wonder if there's any way for us to trim the reading here. But anyway, the up bit rate is definitely pretty good. And you can see we're also tracking the voltage change. That is not a problem either. Again, as I said earlier, it does seem that the reading on this AC range is a little bit higher than actual. I'm not sure if there's any reason behind that, but you can see here, right now the Unity is reading 109.5 and we're reading 111 here. And let's just turn it all the way up to see what we got here. So it does seem that we're consistently reading higher on this ET75 in the AC range. Our next test is the DC voltage accuracy reading, and for that I have hooked it up to my EDC MV216 voltage standard. Now I'm going to adjust the output 1 volt at a time, as we only have a 10 millivolts resolution here, so let's first take a look at the whole volt. 1 volt. Very good. 2. 3. No problem. 4. 5. 6. 7. 8. 9. 10. And you can see that the reading essentially is bang on. And let's just check the least significant digit here. So for that, I'm going to dial in, let's say 1025. So let me do 10, 25, let's do 5, and 20. Yep, no problem at all. It appears that the DC voltage measurement is extremely accurate, unlike what we saw in the AC measurement range. Now let's take a look at the resistance measurement. As we mentioned earlier, this one is only able to measure up to 5 kilo ohm, but let's first short it out. And you can see that actually is really fast. And of course, this is to be expected as we only have a single range here. It appears we have a resolution up to 1 ohm. So let's first measure a 100 ohm resistor. And again, the resistor is precision resistor, but we don't have the resolution here to do that. But essentially, the 100 ohm resistor you can see is bang on. And we can measure a few others, and you can see that the reading update rate is pretty fast, especially for the ohm measurement range. So this is a 100 ohm resistor. And we have a 1 kilo ohm here. Let's take a look. And this is a 4.7 kilo ohm. No issues. Moving on to the continuity and diode testing. So it doesn't appear that it's latched, but there's no issue with that. And because of these are not gold plated, you can see we do have some scratchy sound, but nevertheless, you are able to test continuity pretty accurately here. Now let's measure a diode. And by the way, to switch to different functions, you can see here we have the green marker here for diode. We just press this green button. It's quite intuitive here. The first diode we're going to measure is a silicon diode. Let's see here. Yep, no problem, 0.5 volts. And let's do a white LED, because not all meters can measure white LEDs due to the output voltage. Here's our white LED. Let me get it oriented correctly. Okay, you can see we can light it up, but there's no voltage reading. Now, according to, I think the spec says the maximum measured forward voltage is about 2 volts. So that is actually okay. And let's take a look at what is the output voltage and get a sense of what LED you can use to test. So let's get a voltmeter here. Looks like we're outputting a healthy 4.4 volts. That's actually excellent. So pretty much you can use this to measure any LEDs. And next, let's take a look at the current measurement mode. For that, I have hooked up the Unity and ET75 in series, and using my 6181C current source to drive these 2 meters. Right now, you can see that we're both at 1.527 or thereabout, and they're actually agreeing on each other almost exactly. So let me increase the current a little bit, and we'll see that. So now let's increase to around 10 milliamps. Let's see what we get here. Yep, both agree with each other. And let me just increase to roughly 20 milliamps. No worries. And by the way, the maximum current the ET75 can measure is actually 22 milliamps. So let's take a look at that. Yep, as you can see, right now we're exceeding 22 milliamps and it's over range now. Of course, as I explained in the beginning of the video, the reason you get this ET75 is not because you wanted to use this multimeter functionality, and it's really for its current sourcing and syncing capability, in my opinion. So let's take a look at that. And the first thing we want to look at is the current sourcing capability, and for that we're going to switch to this range here. And also we need to change the leads. So to source current, you can see we have the source that is between this lead and this lead. So now we're going to put the leads in. And I just hooked it up to the Unity ET61E to monitor the current output. Right now it's at 0. And while we're in this mode, you can see we have this arrow that is underneath the digit. So we can use the arrow keys to move that and set our current here. Again, it is very intuitive. So now we're at 1 milliamp. You can see that we are reading back 1 milliamp. Now this one does not have enough resolution. So let me change to a different meter has higher resolution so we can kind of see what exact current reading is. So here I just pulled in my Keithley 197. You can see that we're reading essentially 1 milliamp, but we do see a little bit of variation. I suspect this is because the output has some noise on it. And let's increase the current here. And now we're out of range here. Let me switch it. You can see we're essentially bang on. 4, 5, 6. This is actually quite impressive. As you can see here, the Keithley has 1 extra digit resolution and we're essentially bang on. So let me go to 10. No issues. And let's just go to the maximum. I think 22 milliamps is the maximum, and we'll go to the next one here. And we can see the error in this current output range is definitely within spec. So let me lower it, and let's output not a whole number here. Let's just do, let's do 1, 2, 3, 4, 5. Okay, we'll come back here. We're a little bit out, but that again is well within spec. And by the way, the open circuit voltage output is at around 24 volts, so let's actually verify that. And you can see that indeed we're sitting at 24.38 volts. As I mentioned earlier, the ET75 can not only source current, it can sync current as well. So let's take a look at that. To test its current syncing capability, I'm hooking up the HP6181C in series with the Keithley 197 and the ET75. So both of these meters are in current mode and they're in series. So let me set the current and let's see how much current we're syncing here. So let's do 1 milliamp at a time. So you can see we're extremely accurate here. We're only varying by the last digit here. And 2 milliamps, 3, 4, 5, 6, 7. Yeah, let's take it all the way to 22. No problems at all. So as you can see, we are a little bit off, but that is still within the spec range. And just for completeness, currently we're outputting a 12.345 milliamp current, and you can see on the 197 we're measuring just about 3 or 30 microamps out. And here is a close-up of the display, and it's extremely hard to capture the display accurately as there's some reflection in the lab here, but you can see the display is very sharp. And I do want to point out the reason I'm taking a close-up look is because you can see here we do have these indicators. Right now this is for input range, and later on you will see that this is for output range. So that at least gives you some indication where to put your leads, remind you that you're currently either outputting the current or you're trying to sink the current. That prevents you from putting the leads in the wrong sockets, which would be problematic. You can see here. So that is also for output, as we have seen earlier. Now on to the last two settings here. So these settings, we are actually providing a voltage at the tips here. That's the loop voltage, which is 24 volts nominal voltage. And we are measuring actually the current flowing through the device under test. So let me demonstrate that. So for example, right now, if I put in a roughly 4.7 ohm resistor, we should read about 5 milliamps. And indeed, we're reading about 5 milliamps. And the last one here is basically have an additional 250 ohm resistor in series with your measurement here. So let me demonstrate that. If you recall earlier, we are at roughly 5 milliamps. So right now I'm expecting the measurement to be a little bit less. Yep, we're at 4.7 milliamps. And if I use a 1 kilo ohm resistor, you'll see that the measurement is roughly at 18 milliamps. And by the way, we do have this milliamp percentage button here, and that tells you the actual percentage of the current as compared to the 20 milliamp full range. So that comes in handy when you are doing some of the HART protocol measurements. You don't have to read the actual current measurement, and you can just see what the percentage is, whether or not it's within the specified boundary. So let's take a look at that. And you can see right now we're 88% of the targeted 20 milliamp. Alright, with the testing out of the way, it's time for us to open it up and take a look inside. Wow, let me tell you what, this is actually not something I was expecting in this cheap process meter. And you can see the internal construction is excellent. Let me zoom in and let's take a closer look here. And this section is our input section. You can see we do have this glass fuse that is only rated for 63 milliamps. That's because we only have a 20 milliamp measurement current range. And towards the bottom here on the screen, you can see we do have a PTC here, and that is quite standard. Although we do not have any MOSFETs, but we do have these gas discharge tubes. These are actually not cheap. You can see we have two of these. So clearly, along with the high voltage cutouts, this is definitely carefully considered. These gas discharge tubes can also clamp the input voltage in case there are transients. And let's move on to the middle section here, and you can see that we do have some pretty standard TL062 op amps. And of course, because we have to output 24 volts, you do see a DC-DC converter here. And towards the bottom here, we have some MOSFETs by the look of it, and that's pretty much all the components in the middle section here. And up here, you do see we have this precision voltage reference along with some supporting circuitry, and they are these high-quality capacitors as well. This big component here presumably is a precision resistor network. Instead of using a dedicated DMM chip, this process meter utilizes a MSP430 microprocessor. As you can see, that is the chip right here. And we do have the programming headers alongside here. So now let me just move across so you can get a better view of the board here. And you can see here we have another resistor at the back of the circuit board, and also we have an isolation slot here for high voltage isolation. Okay, originally I was not going to take it apart, but I'm actually glad I did, as there's quite a bit of components on this side as well. There are actually two of these gas discharge tubes on this side. And here we have a few precision resistors by the look of it. And oh, by the way, the VS stitching here is actually for the heatsink of this device here. The chip here is a 2277, which is a low noise op amp. And here is a little bit unusual. This chip here is actually a LM317. That's a voltage regulator. And now I just removed the LCD. Actually, there are additional circuitry under the LCD as well. So here we have a TL062 op amp, and sitting next to it, believe it or not, that's a 555 timer. And underneath here, we have a HY3106, which is a 24-bit analog to digital converter. Of course, this larger chip here is the Holtec LCD driver. And again, here is the LCD screen. And here is the range switch. Those are the contacts. And if you look at the mechanism here, the tension essentially are exerted by those plastic rings. And this is actually a very similar design to what we have seen in the Unity UT61E Plus. And overall, I'm pretty impressed by the quality of the construction here. So I actually quite like the ET75. Its controls are very intuitive and the accuracy is generally very good, except for the AC measurement range. As you saw, the display quality is excellent and the update rate is also decent. In my opinion, just for the precision current sourcing and syncing capability, it is well worth having one. Of course, you cannot compare it to a Fluke 789, but the Fluke also costs at least 10 times as much. I hope you enjoyed the video. If you liked the review, please remember to give it a big thumbs up and remember to subscribe to the channel for more videos like this in the future. I will catch up with you next time.